Welcome to the Seatrade Maritime podcast. I'm your host for this episode, Gary Howard, and today is our second episode speaking with the Wärtsilä Shaft Line Solutions team about their next-level Shaft Line Solutions products. Last episode, we spoke to Paul Naylor, who gave a great overview of the 10-year airguard seal, Evo tube, IntelliSafe bearings, and shaft line monitoring equipment. Give that episode a listen for a grounding in the technologies we'll be discussing today. It was published on September 17th, 2024, if that helps finding the right episode. On the menu for today, I'm speaking with Wärtsilä Shaft Line Solutions' Thomas Pauly, General Manager, Future Portfolio and Market Intelligence, and Henrik Lundgren, General Manager, New Technologies and Systems Architecture. Our conversation dives deeper into the technical details of the next-level Shaft Line Solutions products, as well as the steps that Wärtsilä takes to gather input from its customers and apply that feedback to the development of new and existing technical solutions alike. We cover a specific case study of IntelliSafe in operation on a large tanker and explore the environmental benefits of the shaft line technologies, from cutting the physical material usage in the machinery itself to reducing or even eliminating the need for lubricating oil. Without further ado, let's get into the conversation. I start by asking the guests to introduce themselves.
My name is Thomas Pauly. I'm based in Hamburg, but working globally. I'm in Wärtsilä since 2013, and my job is to collect market needs, voices of customers, translating this into product specifications.
My name is Henrik Lundgren. I'm a Swede living just outside of Gothenburg. I joined Wärtsilä 2011 as part of an acquisition of the company I used to work for. Throughout my career, I've been working with various engineering and R&D roles. I currently have a global role where I'm scoping new technologies for the SLS business. In my team, I also have experts in production and digital engineering, enabling us to widen the scope for introducing new technologies to the SLS business.
We're perfectly placed to cover the topic for today. Let's start with identifying customer concerns and challenges. Thomas, what sort of approach did you take to this process on market analysis, and how do you prioritize what comes up, those concerns and challenges in this process? How do you prioritize those during the development of the next level Shaft Line Solutions?
We are doing this voice of customer survey since 2017. So we have collected so far, I would say, 250 different feedbacks from customers all over the world. So we get their voices, we know what they say. We translate this voice of customer with some Six Sigma tools into needs and what do they mean. We try to analyze how much does it hurt if they won't get it. And the more it hurts, the higher it is in priority. That's basically what we do. And we translate this into product specifications with this prioritization.
Your role, this sort of customer engagement, is that for Shaft Line Solutions or is that across the Wärtsilä portfolio?
No, that is only for Shaft Line Solutions. And our equipment is under the waterline, so we have very special environment, and customers have very special and dedicated needs regarding our equipment.
Sure. And then how does the next level Shaft Line Solutions project, how does that fit into Wärtsilä's long-term vision? What role do the products like this play in Wärtsilä's strategy for the future of its maritime technology?
So basically everything Wärtsilä does, and especially this is applicable to our equipment as well, it's covered in the Wärtsilä way. So in the Wärtsilä way, there are values mentioned, and this is customer success and performance. Our customers want to operate their vessels utmost reliably so they can grow their own business. And that's what we do. We try to develop equipment that enables them to grow their business by operating their vessels reliably with a high performance.
Yeah, off-hire is quite expensive, right? So we want to avoid that at all costs. And then taking it a step forward, how does this market analysis shape the development of Wärtsilä's next level Shaft Line Solutions? What sort of future trends are you seeing in the maritime industry that influence the innovations across this project?
An evergreen trend is, of course, avoiding damages, and this is exactly what we do with our equipment. And a very interesting trend as well is autonomous shipping. So many people talk about what we do with our equipment. We enable customers to operate their vessels autonomously. We have this intelligent bearing. All these are equipments that don't require crew involvement. So customers could operate their vessels autonomously with that. fits into this trend.
Yeah, I guess even if you go to sort of fully autonomous shipping, there's going to be a certain amount of maintenance and engineering that needs to be done. If you can minimize that, then you can minimize the number of people that need to go onto the vessel and how often. Let's move on to the specific technologies, which listeners will remember from the last episode. But starting with the 10-year AirGuard seal, could you explain the technology behind it and what engineering innovations make it better than whatever is already on the market in the terms of sealing solutions?
This journey started 35 years ago. So we invented the AirGuard as the first pollution-free seal on the market because we are the only maker making everything in-house, starting from the rubber recipe through the seal rings, the assembly. We do the R&D, the testing, everything in-house. We have monitored the performance of our seal over 35 years. We found out, okay, it lasts already longer than the normal interval of 5 years. So we checked how much does it need to bring it to 10 years service interval. And we did some enhancements, I would say, in material, in design to bring it to this 10 years service interval. And we are the only maker able to do that because we have everything in-house.
And we're talking in terms of 5 and 10 year to align with special surveys, is that right?
Yeah, exactly. So customers will go to dry dock with their vessel, but at the 5-year stocking and the 15-year stocking, they don't need to touch the seal.
Perfect. Henrik, you've been sitting very patiently waiting for your turn, and we're going to move on to the IntelliSafe bearing. Could you walk us through on the IntelliSafe bearing, the technical design of this product and its effect on reliability and performance in the shaft line?
Of course. The development of the IntelliSafe is partially a result of the extensive voice of the customer exercises that Thomas were talking about, where bearing breakdowns are seen as a big risk for the operation of the vessel. By all means, that is true. In the recent years, we've also seen somewhat of an increased frequency of bearing breakdowns leading to unexpected off-hire. So we have brought our experts together to come up with a possible solution to mitigate these customer input and requests. So the result from the brainstorm was the IntelliSafe, which now is entering the market. The IntelliSafe is based on a conventional white metal bearing used in stern tubes today. One element that makes the bearing intelligent is the addition of proximity sensors in the bearing. These sensors are continuously measuring the fluid film thickness inside the bearing. The output from the sensors is commonly connected to the ECR for continuous monitoring at the ECR level. The monitoring is basically about observing 3 levels: green, amber, and red. Green indicates normal operations, where adequate oil film is between the shaft and the bearing. Amber indicates that the bearing is in an unfavorable condition and that the operation should be changed if possible. Red is then indicating a condition that is pretty severe and metal-to-metal contact might occur. The output from the sensors is also fed into the IntelliSafe pump unit. And the pump unit is what really makes the IntelliSafe smart. The pump unit is supplying oil to the bearing in 2 ways. Normally, the pump is providing tempered oil into the bearing in a forced circulation kind of fashion. In addition, the pump can provide high-pressure oil through an inlet in the bottom of the bearing. The high-pressure oil injection helps to keep the oil film in various conditions. First, it is about creating an oil film during startup to minimize wear before a hydrodynamic film can develop in the bearing. Other conditions are when the bearing is exposed to high loads, like during sharp turns, operating with half-submerged propellers, etc. During these conditions, the pump unit assists to keep an oil film to prevent metal-to-metal contact. The operation of the high-pressure oil injection is controlled by the output from the sensors in the bearing. And if the oil film reaches a certain threshold, the pump is started to regain a normal oil film. The benefits with this is that continuous measurement of the oil film assists the operator to avoid certain operating conditions, if that is possible. And the IntelliSafe oil circulation generally improves the operating condition for the bearing, and it assists keeping an oil film in difficult operating conditions. So with the IntelliSafe, the overall bearing endurance is improved, and let's say the risk for unexpected breakdowns are reduced.
And how does that level of technology compare to a standard white metal bearing?
Yeah, well, a standard white metal bearing is not having any proximity sensor for measuring oil film thickness. The monitoring is basically about measuring temperature. And temperature measurements are seen as quite a slow reacting monitoring system, not giving indication that you're entering a unfavorable condition. And in addition, the high pressure oil injection is something that conventional stern tube bearings do not have, that can react upon unfavorable condition, assisting the bearing to keep the oil film thickness.
I know bearings can often be quite overlooked in other areas of engineering and mechanics. I can only refer to cars that I've worked on and machines in my own workshop, but generally I've learned the hard way that it's worth spending some money on a bearing because if they go wrong, it tends to cost a lot more money in other parts of the machinery. Is this the same case for the shaft line?
Yes, indeed. And especially the aft stern tube bearing is probably one of the most critical components in a shaft line. If you have a breakdown, it leaves the vessel dead in the water and you need to offload and tow yourself to a shipyard to replace the bearing. So that's a great impact on the operation of the vessel, leading to quite extensive costs for the operator.
And speaking about avoiding expensive costs, the shaft line condition monitoring system is part of this series of products. Could you explain how this system works technically and how it contributes through sort of predictive maintenance and system optimization across the shaft line?
The shaft line monitoring system is, let's say, an offspring from a system that we've been using over the years for ad hoc problem solving for shaft lines. This has then been a reactive approach. So the change now is that we are introducing this system as a permanent installation to continuously monitoring the shaft line. And this is now then the proactive approach. The objective is, of course, to spot deviations on an early stage, providing opportunities for predictive maintenance of the shaft line. The system as such consists of a set of non-contacting sensors, again it's proximity sensors, measuring vibration, whirling, and orbiting. Some other features can also be measured, but these are probably the most important ones. Sensors are added in various places in the shaft lines, often in way of bearings, couplings, and flanges. And interestingly, we will be coming on to that later, if the Evo tube is applied. Also, the aft stern tube bearing can be easily sensorized, which today is not very common. Data from the sensors is fed into a processing computer, having an HMI for configuration and display. From the monitoring systems are commonly relayed again into the ECR. If deviations are observed from the system, from predefined values, SLS experts can carry out a more in-depth analysis of the condition of the shaft line and then propose corrective actions. So, in a summary, the monitoring system provides continuous monitoring of the shaft line, which in turn offers opportunities to apply predictive maintenance to reduce risk and cost for the vessel operator.
In the voice of customer, for example, there was one market need mentioned: please, can you make underwater equipment visible? And that's exactly what we are doing with this monitoring. So we take this operational conditions of this equipment from underwater to the engine room and we make it visible. So this is perfectly meeting one of the market demands.
Sounds like it all aligns well. Henrik, you mentioned proximity sensors, which I suppose is just measuring the distance between two surfaces, but also, was it whirling and orbiting? What do those sensors do?
Yeah, well, they are measuring how, let's say, the shaft is moving inside the bearing and creating a pattern that can be, let's say, looked upon and analyzed. Unfortunately, I'm not the true expert of proximity sensors, so I can't give a very comprehensive answer on the topic, unfortunately.
Sure. I'll go away, do my research, and probably fall down some kind of rabbit hole on Wikipedia.
Yeah.
Okay, let's move on to the next product then, the Evo Tube stern tube, which we've already mentioned. Again, another critical part of the shaft line. Could we talk about the technical reasons that led to its development, and again how it improves upon the current state of the technology, the traditional stern tube designs?
Of course, I will be covering this one since this is really my little baby. The Evo tube concept was first presented actually back in 2014. In 2016, we applied for a patent, and now we got a patent active in Europe, Korea, and China for the stern tube concept called Evo tube. The concept as such is the result of many years of designing and manufacturing conventional stern tubes. The conventional stern tubes can be quite large, heavy, making them difficult both to manufacture, handle, and install. Additional piping and sensors in the stern tube are continuously added, making both the design and manufacturing quite a challenge. During installation of the propeller shaft, there is always risks for hitting pipes and cabling inside the stern tubes. And back in the days, demands for water lubrication came along. And commonly, conventional stern tubes are used also for water lubrication. And this requires extensive corrosion protection of the stern tube as well as the propeller shaft passing through the stern tube. The use of a conventional stern tube for water lubrication is therefore quite complex, and there is always a risk for corrosion, having a large portion of both the stern tube and the shaft exposed to seawater. So all this in combination led to the idea to more or less completely remove the stern tube, and the result is what we today call the Evo tube. And for the Evo tube, the aft bearing is the same as for the conventional stern tube, so that is unchanged totally. The forward bearing, on the other hand, is replaced by a plumber bearing, which is located inside the engine room. And the forward seal that normally sits on the bulkhead seal on the stern tube is then moved into the aft peak bulkhead and mounted on the bearing housing for the aftmost bearing. So from a bearing alignment point of view, the Evo tube is identical to a conventional stern tube, so there is no change in that sense. The Evo tube can be designed for both water lubrication as well as oil lubrication. And changing lubricant for the Evo tube is quite easy since it's only affecting the aft bearing and associated seals. Remaining components in the shaft line remains exactly the same. So adopting Evo tube for oil lubrication can then be seen as a preparation for upgrading to water lubrication in the future if that should be required. And some other advantages with the Evo tube is that we are using much less material. We removed most parts of the stern tube, leaving only a housing for the aft bearings. So we are using much less material. And this in turn simplifies manufacturing. You don't need to put up 10-meter long pipes in a machine to machine. It's limited to a bearing housing for the aft stern tube bearing. And of course, then shipping, storage, and handling becomes much easier since you don't need to handle a big and bulky stern tube anymore. For the oil lubricated configuration, we are using 90% less lubrication oil. I was looking at a 10K container vessel that we made a stern tube for many years ago, and that contained 1,400 liters of oil. And by introducing the Evo tube, lubrication volume is reduced to some 700 liters or something like that. And the mass went from 15 tons to 9 tons. So there is a great saving, which then can be translated into a decarbonization action. The installation and alignment of the Evo tube during new build is greatly simplified since the bearings for the propeller shafts are both installed and aligned individually. For a stern tube, normally there is 2 bearings, and those are pre-aligned, let's say, in the stern tube, which at times are creating issues. So the Evo tube, the bearings are aligned individually. And during installation of the propeller shaft, there is no risk for damaging piping or cabling that is running through the conventional stern tube since there is no stern tube, so the cabling is way out from harm's way. And as said, having no stern tube also provides opportunities to install additional sensors in the aft bearing. Since you don't need to thread it through the stern tube, you thread it outside, so it becomes much easier to add additional piping and cabling. And also, if you're sensorizing the aft bearing, these can be accessed from inside the vessel rather from outside, and this is an advantage if you need to, let's say, replace a sensor. For the water lubricated configuration, it will also be possible to exchange the aft bearing afloat. So this is quite a new thing, and this is achieved then by using a split composite bearing that can be replaced by pulling it into the vessel rather than pulling it outside the vessel. And this means that you do not really need to do anything, disassemble anything in the shaft line, except removing the seal and pull the bearing out inwards. So in summary, introducing Evo tube comes with a multiple of advantages that should apply to, if you can name it like that, the entire food chain from design to manufacture to installation to operation and eventually also on to maintenance.
There's a lot of changes from one product. I like the idea of, I think the shipping industry is getting used to the ready notation, whether it be for a new fuel or for wind power. And the idea of being water lubrication ready is a new one to me, but it sounds like something that's kind of built into the product there. You mentioned that the idea and the designs first came together in 2014 with a patent in 2016. 10 years is quite a long time from the idea to market. What was the reason for that? Is it just because it's such a big change to the existing setup?
It takes time to digest a big shift in how things are being done. So the conventional stern tube is so established, and if someone all of a sudden presents something that is completely different, it takes time to digest. And also the introduction of the Evo tube requires some redesign of the off-peak of a vessel, meaning that we need to have buy-in from multiple, let's say, parties to actually go for changing the vessel design to fit an Evo tube. And what needs to be changed is the layout of the off-peak, enabling you to enter the off-peak to do maintenance on the stern tube seal, which is located there, and also for potentially exchanging the bearing. And these changes are not coming overnight, let's say. It takes time to introduce and get the market and all the stakeholders to understand the advantages and actually taking the leap. To a certain extent, it's also the implication of who will go first. Building a vessel is quite an investment, and to do bigger changes isn't coming easy. So that, I would say, is some of the reasons why the introduction takes quite a bit of time.
Yeah. Thomas, did you have something to add on that? I thought I saw your hand go up.
Basically, it is seeing is believing. And since we have this modular test rig in Porriño in Spain, what we did there, we brought it to a constellation in Evo Tube. So we did this Evo Tube constellation on this test rig. And so this is basically a breakthrough. We can show now all the stakeholders how it looks like, how it works, and you can see and feel and touch the advantage. So this is basically a big advantage having this test rig in an Evo Tube constellation.
This seems like a pretty massive change, Thomas, to everything in that area of the ship. Was this a reaction to these sort of customer surveys that you do, or was this sort of a more pure innovation on the side of Wärtsilä?
So these voice of customer interviews, it contains, I would say, 50 different questions. And we take these questions and we look which idea does it support. And yes, the Evo Tube, for example, enable monitoring. Yes, the Evo Tube enables monitoring. Another voice, make it easier to service. Yes, of course. The Evo Tube makes it easier to service, bring down costs. And what Henrik mentioned, water lubrication. Yes, this Evo Tube makes it easier for customers to apply water lubrication. Going from oil to water, this would be easiest with Evo Tube.
Just sticking with you, sustainability it's obviously key in the maritime industry, and I'm sure it's something that you hear plenty about from your customers. From a technical perspective, how do the innovations that we've spoken about, how do they contribute to Wärtsilä's own sustainability goals?
Yeah, so basically sustainability includes many things. What we do, we try to minimize oil consumption, avoiding ship damages. If you have a ship damage, you have massive oil pollution, you have huge oil spills. So we avoid this with our developments. Risk of accidents, and basically it is minimizing the environmental footprint of a vessel. That's what we do. It's reducing metal, so makes it easier, cheaper, and it reduces the material in shipbuilding. 10 years air guard, it saves 2 times servicing the seal. IntelliSafe and monitoring, this is basically lubricating the shaft line as good as possible. And this all is basically minimizing the oil consumption on a vessel.
And then obviously these things are out in the wild. What sort of feedback are you receiving from clients who have adopted these solutions, who have seen them in action and experienced them operationally?
I can talk about one case, and this is with the IntelliSafe, where we are following the operation of one selected vessel. This is a larger crude oil tanker operating on a spot market. And the first observation the operator did was that they saw that the general operating temperature of the off bearing has been reduced and stabilized. And this is then, of course, through the general circulation and cooling of the lubricating oil from the IntelliSafe auxiliaries. During the operation, we have observed 2 amber alarms. So it's like a highlight. It's not it's an unfavorable condition, but it's in the upper, let's say, threshold. So 2 we have observed, and the operator says that these amber alarms, they're actually assisting the crew to avoid certain operating conditions going forward. So the crew is learning what is potentially damaging for the bearing and can avoid then a certain operating condition. Doing this will, of course, reduce the load on the bearing during the operational life cycle, which in turn is then beneficial for the endurance of the bearing. Worth mentioning is that during these amber alarms that the vessel experienced, the operating temperature did not increase. And this is then the current monitoring system, which is temperature sensors in the bearing. They did not react. So this indicates that the IntelliSafe provides early alarms that the current monitoring system is not able to detect. So for us, introducing the IntelliSafe is a bit of a milestone for safe operation of the aft stern tube bearing, which is, again, then one of the most critical components in a vessel shaft line. So that is the feedback that I've received so far on the new solutions.
You answered my follow-up question there, which was going to be what would happen if there was a standard bearing, but it sounds like there would have been no indication, I suppose, until things got worse and the situation was bad enough that everything was heating up.
Exactly. And normally during a bearing breakdown, it's when the temperature is rising, it's too late. You're in for a breakdown. So the temperature sensors, how they are mounted current today, is not good enough to detect an unfavorable condition. And here we have, let's say, 3 thresholds from normal to you're entering into something dangerous to a really dangerous. So it's very proactive.
Thomas, I suppose that's one way of measuring the performance, is to have a specific vessel that you follow. But once these innovations are deployed, how else do you sort of technically measure their performance out in the field? And what are the key indicators of success that you're looking for?
In the past, it was always a surprise in dry dock after 5 years. So customers saw the condition of their equipment after 5 years when they opened the system. In the meantime, it was no news or good news. So this was so far. What we do with this monitoring, and this IntelliSafe has monitoring as well, we collect data. So this is the data part, and we can see based on the data how good the vessel performs, how close it is to a damage. So this is the data part. And of course, we will interview customers again. So customers that mentioned this need, hey, I would like to have something to solve this problem. We applied the solutions, and after a couple of years, we will interview them again. Hey, what is your experience? And they will feed back. And the best positive feedback would be, hey, no news or good news. So if they operate without crew involvement, perfectly fine. That's how we do it.
Well, I guess the very best feedback would be them buying more, right?
Yeah. So
we've covered a lot of products, and hopefully listeners have got some more technical details on the products that we introduced in the last episode. But just finally, let's have a bit of a look ahead. How do you envision the next technical developments in Shaft Line Solutions? Are there any upcoming sort of technical features or upgrades that we should expect from the Wärtsilä range?
I can answer that. What we see, the industry is going to decarbonization in various aspects, but basically it is they decarbonize their ships. We can help them on their way with our equipment, Shaft Line Solutions. We are collecting this feedback in detail now. Look, how can we help you on your decarbonization journey? Doing some small steps, or basically making this bigger step, for example, towards water lubrication. So removing stern tube lube oil completely. We had an interesting discussion with one customer. He told us, look, every single liter of lube oil I have in the vessel, it has an own carbon footprint. So it needs to be taken out of the earth, refined. It needs to be shipped to the vessel. It needs to be recycled somewhere later. So the environmental footprint of 1 liter is quite big. removing a few thousand liters would be good. We are interviewing customers at the moment. How can we help you doing small steps or doing a massive step?
I totally agree what Thomas has been saying, and to me, it's up till now it's been about making small steps. Let's say from an engineering point of view, trying to reduce the amount of material we're putting into our products, reducing the amount of oil that we need to have in the product, and sort of trying to affect the entire value chain, if you will, with our products. Eventually, of course, the big thing would be to switch over to water lubrication eventually, which will then greatly reduce or totally reduce the use of lubricating oil in our products. That will be the big thing if we will eventually see this breakthrough, which is technically challenging, and hopefully the EvoTube could make a bit of a difference to encourage the market to go in that very direction.
Fantastic. Well, gentlemen, thanks both for your time today, and thank you to the listener for listening in to the Seatrade Maritime podcast.
Indeed, of course. Thanks a lot.
Thanks, it was a pleasure. Thank you very much.